So today we're going to look at this free-falling object problem where we start on a very tall roof and we're throwing a ball directly up with a velocity of 15 meters per second. And in this part, we're just going to find the position and velocity at 1 second. So the first step is always to identify our givens. So in this problem, it gives us the initial velocity equal to 15 meters per second, and the direction is up. That is important to know. Our next step is to identify what we're solving for. So in this part, we're simply just be looking at time equals 1 second, and we're going to find the position and the velocity. And then the next step should be to identify the equations needed to solve. So we're going to need the position equation here, and we're also going to need the velocity equation. These are pretty standard for any 1D motion board problem. So in a question like this, it's really important to draw a diagram so we can see what's going on. And I just want to note the first thing we should do is to define a coordinate system. So we're going to define the up direction as positive. And so we can start by identifying the tall building here, then drawing the ball with the initial velocity vector pointing up, and then we can draw the general motion the ball is going to follow, as well as we can draw the gravity vector, noting that the gravity is going to be equal to negative 9.8 meters per second squared. And it's negative because of our defined coordinate system. Remember, we defined up as positive, so it's in the opposite direction. And I also want to note that the ball goes directly up and directly down, but in our diagram it is a loop. That's just for us to better picture the motion. And we can also label our initial height YO, and I just want to note that YO is going to be equal to 0 because it's our reference height. So now we just have to solve. So for time equals 1 second, we just need to find the position Y and the velocity Vy. So we can start by writing down the position equation and plugging in the values that we already found. And so if we plug these into the equation, we get this expression here. Do the multiplications of the amplitudes, we get 15 times 1 equals 15. And if we multiply the units, meters per second times second is just meters. And then on the right hand side here, we can look at the 1 second squared terms. So if we square both the units and the amplitudes, we get 1 second squared. And that would leave us with this expression here. So then we multiply these amplitudes and we get negative 4.9, and then we can multiply the units and it leaves us with meters. So if we plug this back into the equation, we get this expression here, and we just do the subtraction and we get the final answer. So I just want to note this answer represents the height at t equals 1 second. So if we draw the diagram here, and we can label the initial height and we can label the time at 1 second. So this distance here is going to be the position we just found. And now we can do the same thing and find the velocity. So we start with the velocity equation and then we plug in our known values here, and then it leaves us with this expression here. And then if we just multiply amplitudes, negative 9.8 times 1 is negative 9.8, and then meters per second squared times second, one of the seconds cancel, and it leaves us with meters per second. Then we plug that back in and we get this expression here, and then we do the simple subtraction, 15 minus 9.8, and it leaves us with 5.2 for the final answer. And I just want to note that this represents the velocity when the ball is at t equals 1 second, and we can see that the ball has already lost a lot of velocity due to gravity. In that 1 second time, it already goes from 15 meters per second to 5.2, so that's a lot of velocity, and therefore we can conclude that the ball is definitely decelerating.